Hi, welcome to Python Lesson 2 for the BVCN. Today we're going to talk really briefly about data types and then go into a tutorial that explores how data types function within Python. So what do I mean by data types? It's actually a pretty straightforward list of things that we're interested in. So there are two major categories of Python data types. The first are immutable data types, and the second are mutable data types. This lesson is only going to discuss immutable data types. And so these are data types that by definition can't be changed. And so what that means is that once they're set, these data types are static until you replace them with something else. And that if you do replace them with something else, it replaces that earlier state with the new one that you've set it. This is different from mutable data types, which are able to be changed, and they exist as an entity that incorporates multiple other elements. So that allows you to say, okay, I want this element, not that element. I want this element in this different order. It allows you to make those changes to it, right? So we're going to be working specifically today with the immutable data types. And those immutable data types include numbers, strings, right? So anything that has alphanumeric components to it, and then tuples, which are defined as similar to like an X and Y position on a graph. It's a two entity element that has an X and a Y as part of it. And so to give you an example of what some of these numbers and strings and things might look like, I've highlighted here in yellow the elements that we'll be talking about today in the tutorial, and then in white the elements that are more broad and are the mutable data types that we'll talk about in the next lessons. And I specifically want to highlight the elements that are above this black line because that's really what we're going to spend a lot of the tutorial on. And that's addressing how numbers work. So ideally, the difference between an integer and a float. And so, as you might expect, an integer is a whole number, while floats represent our decimal number friends that are out there. And then strings, which represent our alphanumeric characters, but also can include numbers as well, right? And so we'll talk a little bit about how strings of numbers behave differently than numbers themselves as the data type. And then everything else in white, lists, dictionary sets, Booleans, we'll discuss more extensively in lesson 4, which is what the next slide says, which is lesson 4. We'll cover those elements. So for this tutorial, we're going to be using have the repo in our BVCN GitHub, the one that's titled Python. We're going to be in lesson 2. And what we're going to do is we're going to launch our binder from here. I'm going to launch it as a separate window so that we can talk about it. This is going to take a second to load up depending on when the last time the binder was run and how many people have worked on it recently. Okay, and then to get started, what we're going to be working with is we're going to be working with this tutorial IPython notebook. And so this is going to bring up an element in our browser that's going to allow us to not only look at the content that we're working with, but also to execute various cells as part of the code. So we can manipulate the code as we go and create an output. And so it's set up here for those of us who aren't present in the live tutorial to follow along, or who maybe stumble across this just by accident. But for everybody else, what we're going to be doing here is we're going to be working with, again, the immutable data types that are available as part of, that come in, that are Python, essentially. And so what we're going to do in this first section is we're going to talk about what I've done here in terms of the code block, and then we'll end it all off with using the print function as part of the output that we will want to see to be able to look at what we've generated, right? So right now what I have are a number of our immutable data types, which I've set using variable names using equal sign. So here I have Q set with an integer called 6. And so Python automatically knows what type of data type this is, right? And so we'll see in a second that it's actually able to register by me just giving it the number 6 without any other elements to it, that it's generating an integer data type inside this variable. Here we have a string data type that I've named with the variable W. What you have to do for strings is to present it in a way that Python can interpret it to be a string. And so there are two ways that we do that. The one way is concealing it around double quotes. We can also, and it is equivalent to also set it like this, where we have used a single quotes. And you can see that pops up as part of the Python aware elements of the notebook. And so in both of these instances, we're able to set W as a string character or a string variable. And so it's important that we recognize this, because it means that going forward, that these particular characters represent special entities within Python, because when it sees it, it's looking for the closed version of it to define something as a string. When we move down to the next one, we have a variable named e that consists of a float. And so here, but just by adding the decimal and a number, another number after it, Python's able to interpret this as a float. And then here's an example of a tuple, which is a paired item that comes in, similar, like I said, to a data point on a graph as an XY element. And so these are our immutable data types. These are what we're going to talk about for this particular example. And then in the next lesson, we'll talk about mutable data types, which include lists, sets, and dictionaries. So our first thing that we want to do is we want to execute our print command. And so here, what we're saying is print W. Then I've included here a string, the word is, and then also a function within the function, which is something that Python likes to do and happens often, where we're asking Python to return what type of data type the variable is. And so in this case, we're asking for W. And so there's a couple things here that we can unpack that make print one of the most common and regularly used functions as part of Python, is that I've demarcated what I want printed out with these commas. And so what will happen here is Python will automatically put in white space for those commas. It tends to not always be the white space that you want. So we'll get to a way where we can actually build strings to be printed the way that we want to, and how that's handled in a second. But right now, if we were to run this code, so now we've set all these variables. Here I've set the variable W to hello there once, and then set it again. So it's exactly identical to the first iteration of it. So W won't change here. The difference between the two quotes won't matter. And we can hit this play button here to run this whole cell of data at one time. And so what happens is we get, because all of these are just setting variables, nothing happens. And then we get to the very end and we ask our print statement to happen. And so we get, what is W? W is the words hello there. And and that variable also is considered the type string. And so we can do this, and we can replace this, and we can do it with Q. And you'll see that a similar thing happens. But now Q, because we've set it as 6, and we run it, and we can rerun it again using that play button, and it's the class integer, right? Which is what this next line says. And so what we want to do is we want to redo this whole segment. So we did it with Q and we did it with W, but we also want to do it with R and E. And so we can do that in a couple ways. So if we move down to this next cell, we could do something like this. So something you might have noticed is that there are these lines that have these asterisks in front of them. Not asterisks. They are pound signs, sorry. You might have noticed these lines that have pound signs in front of them. And so these pound signs are representing lines that have been commented out. And so what we can do in a couple ways, we can delete this and now make this an active line of code. And so the difference between that, so I start with the pound sign, I hit run, nothing gets printed out. If I go back here, delete the pound sign, have it run, now we get a similar output to up here, but because I didn't put the word is to make it a sentence, it just gives me the variable output and then the data type that it is. And so we can manipulate this in a couple of ways. We can do this for all of our elements. So we can do this as print W and then type W. So if we rerun this now, not only do we get our Q output, but we get our string output as well in our W format. And we can keep adding to this, right? And we can do print E type E, and I'll do it at the same time. I'll do print R type R. And now if I hit run, what happens is we get all 4 of the lines coming out at once, and it's keeping track of our variables from up here. and then returning what type of data type that Python is interpreting it as. So here we have our E is being returned as 42.42, and it's the class float. And then we have our tuple that's being returned, and then in Python knows it's a class tuple. So what we can do here is we can actually play around it. So Python allows us to take one data type and force it to be another data type. And this has really interesting properties and sometimes complications to them. And so what we're going to do is we're going to play around in our tutorial GitHub repo. There's a table 1, which talks about the various outputs or the various data types that we can work with. And then the Python method that we can use to convert elements from one to the other. So here we're going to work with a float that's in the variable t. And so we want to convert these to different data types. And so here what I'm doing is setting a new variable which will represent the converted version of t. And so in this instance, what I'm doing is I'm taking t and I'm saying, hey, make this plain text by forcing it to become a string. And I'm setting that variable y. And so here, what will happen is that we're going to use this print statement. We're going to get this output up here. And you'll notice, if I add this here, print t type t, is that we'll convert t from its float type to its string type element. Right, so now it looks exactly the same, but the y is no longer a float, but it's actually a string. And so this has implications because what it means is that instead of acting like a math term going forward, the variable y, even though it has the number 63.21 in it, will no longer function as a math term. It'll function as a word or a string of characters going forward. And so we can do this. So let's do this with all the types that we were working with before. And what we'll see is, so we're going to set a couple different variables. I'm just going to set a couple here from the keyboard. So here I'm going to make it an integer for t. I'm also going to set b to be Boolean. So these are true false. You can have Python code true false to be part of what you're looking at as set special data types. And then we're going to set a couple things that are down here that it'll be very upset with. So we're going to just do s equal set t. We're going to do d is equal to list. And so you'll see these are a lot of our mutable data types. But what we're doing is we're actually setting the range of it incorrectly, right? So because a lot of these data types want elements to them that have more than one, we'll probably get some errors going forward from this. And so if I wanted to do this and then do a couple of print statements, so we can do print a, type a, we can do print b, type b, we can do print s, type s, we can do print d, type d, and then print, lastly, f, type. Okay, and so now I'm going to hit enter or run on these to get them to run, and we'll see what the output is. So we have our original here, which is our float and our string, and let's see what happens. All right, so we get a bunch of errors. And the first error we get is that we tried to set our float as a set, this s variable, right? We tried to set t to be a set, and right here it says, oh, we can't do that because our float object is not iterable, right? So we actually can't convert our particular variable type, data type of float into a set. So we can comment out this line and we'll try again. We're going to get another, oh, sorry, I want to go up here. Comment out that line and try again. Okay, and so now we've just moved on to the next list. We've again done the same thing. We've tried to take our single mutable object and move it into an object that it can't exist in, so we get this error. So again, we'll comment that out, and we'll comment this out so we don't get an error for that print. And then we'll run that. And then again, we'll get our last one. So we're sending tuple a single element here, right? But we know that tuples require two elements, an x and a y. And so again, we get this error. So we're going to go, okay, well, we don't want that. So now we're left only with these other elements that were all part of our original list of elements that we could work with. And so now when we run this, what happens is we get our elements back that are able to go from the immutable data types to other immutable data types. And so what happens is that we've set A as an integer and we've set B as a Boolean. And when we print those out here, and then it comes out this line. So a couple things to point out. The first thing is that because we set this as an integer, we took our float, which has decimal points, and we removed those. So it's no longer a float class, it's an integer class. And so one of the things you can see, and maybe this makes logical sense, is that we had 0.21, and that when we removed it, the output gave us the whole number that was related to. And you might think that this is because Python is rounding, but we can actually make an adjustment here. We can say, let's say 78. And what you'll see is if we run the code here, it still is the 63, right? So there's no rounding that happens here. It's just converting your float to an integer by removing everything that's after the decimal point, which is not ideal if we are hoping for it to round, right? And to keep track of what the number might have been closely. And it's also important if we're trying to keep track of those decimals, right? So if we have at any point a variable that we convert from a float to an integer, all of a sudden we lose that extra information that was after the decimal point. The other thing that we are, you'll notice is that, so this class Boolean is its own special entity. And so I just mentioned that Booleans in Python can only exist in two states, and they're special states. It's either true, which is denoted by capital T, true, or false, which is denoted by capital F, false. And so here, by setting this variable with a Boolean that has an element in it, we're automatically setting the value to be true. And so the only other way we could do this is if we get rid of the T here and just set B to be a Boolean. And now when we run this, because we set it as a Boolean type, but didn't actually give it anything, we didn't tell it if it's real or not, it actually returns that false option. So either true or false, right? And so we could do this, we can even add, anything we add here, 4G elements like that. Let's make it a string to make sure it's not, right? So it's basically gobbledygook, but when we hit run, because there's something here and we've converted it into a Boolean, it makes it, it keeps track of that as being true for that particular variable. And then the last thing we want to talk about, so we've been playing around pretty simply with the print statements, and up here, we talked about how by putting in these commas, I was able to have each of the individual elements output resembling a sentence, but not exactly being a sentence. And so here we can try this with what's normally very commonly used to not only works, doesn't only just work in math, which we'll get to in future lessons, but it also works with strings where we can use the plus sign to stitch strings together. And so the first thing that we're going to do is we're going to try and run this particular bit of code and look at what happens. And so when we run this, we actually get an error. And that's because there's only one element in this whole setup right now of this print function that is a string. And that's the letters that are occurring between these two double quotes. So currently W, which we set previously up here, W here is set to a string. Okay, so there are two things set as a string. But this type here, you can see, we've been doing this so far with the entire lesson, is this type actually outputs this very interesting output here that makes it difficult. It's a type output, right? So it doesn't actually exist, even though it looks like a string, it doesn't exist as a string. And so we need to do a couple things to do this. So let's try this. Again, we can do this. So let's do something like this where it might be more difficult to do this, where we know Q here. So again, we're getting a different error here. And that's because the integer Q actually it also doesn't act like a string. And so what we want to do is we want to take what we've learned here with our ability to force Python to treat elements like other elements and do that as part of the print statement. So we could do something like this where we say string Q. So now what we're doing is converting the integer Q into a string within the print statement. And then we'll have to do something like that too here. And you want to make sure that there's enough closed parentheses because the automatic closing of the parentheses happens in the Python notebook. So if you didn't notice that, So here I put my cursor. I'm going to try and put in a closed parentheses. I hit Shift, Enter. It added it, but it added it in the way to close this other open parentheses. So now I still have an open parentheses over here. So I wanted to close it all the way by adding my third one on the outside. And so now if I run this, what do I get? I get something that doesn't look that appetizing. It says it's converted all of our elements that weren't strings into strings, and then it's stuck them all together with our plus signs. And so that's the other thing that comes in here that we didn't run into up here. So up here, Python could handle each of these elements individually and knew that because we put it into a print statement, we wanted to convert them to a string and output them out in the print statement. And then because we had separated them with commas, it gave it some white space to work with in between it. Here, what we're working with now is that we have a string, a plus sign, the letters IS, but there's no automatic white space added here. And so if we want to add a white space, we have to do it manually. There's a couple different ways we could do this. We could do it here where we add a space before and after is, and then rerun that code. And now we have spaces there. We could also do something like this, where and this is like super long form, we add another plus sign, we add another string, and then we manually add a space here. Do the same thing here, where we manually add space. So now we're creating a final string that has 5 elements to it, the string version of the integer q, a string that has an empty white space in it, which is something that we're allowed to do, a string that has the characters is for the word is, another string that has an empty white space in it, and then a string which has our output of data type for the data type W. And if we rerun this, we should get the same string output. Okay, so let's move on to our next section. And so this has been talking about our variables. We're going to talk specifically about the data type string and how we can use that to manipulate our the built-in functions of Python to manipulate the output of a string element. And so what you'll see very commonly, and so we have it here in table 2, is that there are these built-in functions that manipulate strings. These are a small selection of how these elements that are out there. There are others. And what we normally do is we set it up by saying, set the string, whatever the string variable is, we put a period, and then we have the function run, and then it's a set of parentheses. And this works, in a couple ways. So if there's no actual extra variables that you need to set, you can just have an open and close parentheses. And then there are some functions that require you to set other elements to them, and we'll put those inside those parentheses elements. Okay, and so our first one that we're going to work with is this function strip. And what strip does is it removes the leading and trailing characters, the white space characters from a string element that you presented. And so I've set 2 variables here. We're going to work almost exclusively with sequence until the latter part of this demonstration, where we have a sequence where I've included a DNA sequence here. And then right now in the front and in the back, I have new lines. We can actually change this to make it similar to before, where we're actually working with spaces. So we have a white space in the front and a white space in the back. And so when we work with this, it's going to be pretty difficult to see what that looks like. Let me show you what I mean by that. So if I go here, go down the line, and I say print sequence, it's not going to look that dissimilar from what we've seen before, right? It prints out our elements for us, and because it's white space, we actually can't see where it is. And so what we want to do is we want to compare this sequence output before and after. We use strip, and one of the easier ways to do that might be stringing our sequence together with itself. So here I'm just using sequence plus sequence, so I'm taking our 2 strings and putting them together. And then because they both have white space, not only at the front but at the end, what we'd expect is this string element plus some white space and then the string element repeated. And that's what we get, right? So we get white space, double white space, and then white space at the end, which is not what we were intending, right? So what we can do is we can have in this format, we can take our string sequence, run the function strip, and by not presenting it with any variable here, it'll just do white space. You can see here in the table that if we gave it a particular string set, we could actually have it strip that element, both the leading and the trailing element from that. So we can play with that in a second. And so now when I do this, so I take sequence, I run stripped, I'm going to remove the white space, I reset it to sequence. So in this particular situation, I'm taking the original string, running it through a process, and then saving it back in the original variable, which will destroy that first version of sequence that we had that had 2 white spaces on either end. So now when I run this, what'll happen is all of our white spaces are gone, and it's been strung together, and it's now sitting in our sequence space, or in our sequence variable. And so, like I said, we can do something like this. This gets pretty interesting. So now we have our sequence that looks like this, and we have our our leading is character is an A, and our trailing character is a T. If I were to put an A here, again, setting our variable here. So sequence now. So not only are we going to change this A, but we're going to change this A too, because that's the leading character for these 2 strings. If I hit this and run here. So what I've done is I've changed this to a T, and I've changed this one to a T as well. So you can do that as well with other variables. And so you saw in this particular instance, because I had already run this cell once and removed the white space and then saved it as sequence, we had that new version that we saw, which was strung together. And now I've done it again, and I've replaced all the T's with A's and generated a new sequence and generated an output that way. So now we have a longer sequence that we can work with for the next set of instructions, where we're going to work specifically with upper, lower, and replace as our functions of choice. Okay, so the first thing we want to do is we want to print our new. We're going to work here with lowercase here. We want to print lowercase, working with our sequence without changing the variable. Okay, and so we can do that pretty easily by running print sequence, and then here we can actually call the function within, just like above, we can call the function within the print statement. So now when I run this, what's going to happen is we're going to take our, that's not how you spell sequence. That's not how you spell sequence either. We're going to take our sequence variable, we're going to convert it from uppercase to lowercase, and we're just going to print it out. And so we did that, and that's right here, but now we can compare this with what sequence actually contains. So the variable sequence here, when I print it, still is all in upper cases, right? So we're able to maintain our original variable by printing, but by asking Python to print out just the lowercase version of that. And so we can do this. We can set this as a new variable here. So we can create a variable called seek lowercase. We can take the variable sequence, and we can make it lower, and then we'll want to make sure we want to print this so we can actually see what it looks like. So we're going to print seek lowercase. And now when I run this, we'll have our first 2 lines and then our second 2 lines where we're going to set, or it's just going to be 1 line, where we're going to set our new variable to be sequence lowercase by running this function and then printing to see what that looks like. And so you can see right here, what we've done now is we've maintained our original sequence where it's all lowercase. And then we've also created a new variable, which has a string data type that is also all lowercase. And so then the last thing we want to do is what we've done up here is where we reset sequence to be something, to take the original version of sequence and then reset it. And so there's a couple ways we can do this. So we can do sequence equals sequence dot lower. And so this is going to take our lowercase, or it's going to take our sequence, it's going to make it lowercase and then save it in our sequence file, or sequence variable, sorry, not a file. And then the same thing can happen here, where if we did something like sequence, and then we can set it using our seek lowercase. So in this particular instance, what I'm doing is, because I've already saved our lower sequence string into the variable seek lowercase, I can set our original sequence variable with this new variable that we have here. And so what we would do is we would transfer this lowercase versioning back to our original sequence variable. And so both of these ways work. And then if we print it out, so again, we're going to hopefully see here, we're going to see once, so this will only work the first time, but in the first time we should go print the statement, we're changing we're going to convert sequence to lowercase without changing the variable. We can prove that by printing the variable again. We're going to convert our sequence string into lowercase and save it as a new variable and print that. And then here what we're going to do is we're going to change our sequence variable using the contents of our lowercase variable and get that. And so what we would expect is lowercase, uppercase, lowercase, lowercase, which is what we get. But now, if we were to rerun this cell, what's happened is that we've saved sequence to be lowercase. So this print statement, which was originally all in uppercase, when we rerun it, will be lowercase. So now we just get 4 lowercases. So we can, we've taken our string, we've converted it all to lowercase. We can do the same thing and flip it on its head and make it all uppercase. So again, we want to take our sequences and we want to make them uppercase. And so we can do it the same way as we did before, where we do print sequence upper. So this won't change our variable and the string within it, but it will create our uppercase elements. And then we can also do what we did previously, where we can create a variable called seq uppercase, and that can be equal to sequence.upper function. And then we can print that seq uppercase and then hit print. And again, so we've taken our sequence here, which was originally set as lowercase, and have now reset it as a new variable with uppercase. And so we want to make sure that when we go into our next section, we actually have this set again. So we're going to do our sequence is equal to sequence.upper. So now we'll have all upper sequences for it going forward. Letters. Those are letters. So we'll have uppercase letters going forward. Right. So now we've saved it again in our sequence variable, where now we have all uppercases. So the last element that we want to talk about for dealing with our sequence space is going to be this replace function. And so this allows us, using this format of string, replace, and then giving it 2 elements, we can take our elements in our string and convert them from one to another. And so this is useful in this particular instance with sequence space, because we can convert our DNA to mRNA if you were changing all of our T's to U's, right? And so we can do that pretty easily. We can do something like this, where we're going to do our print statement. We're going to take sequence. So before changing it permanently, we're going to do replace. Here we're going to actually include the variables, and so there's important elements to this. We're going to open and close the parentheses to denote the fact that it's going to be a function that we're running. We need the you can do either single quote or double quote here, but you need to have the string T listed as the first element. So that's what we're going to look for. That's the original. And then we're going to replace it with the string U, and that'll be this element here, the replacement. And so now when we print this, we've now taken all of our T's and converted them to U's, right? So a pretty simple way of addressing that. This becomes one of those things that we can, obviously make more or less complicated as we go. So here I can do something like I can take all of our T's and I can replace them with the number 42, right? So again, we're not treating 42 as an integer, we're treating 42 as a string element. And so when I hit run on this, so what I get is our first replacement, where we take all our 2's and make them U's, all of our T's and make them U's. And then here I've taken all of our T's and made them the number 42. So not logical for what we want to do going forward with biology, but it allows us to make those manipulations as we want to go. So we're going to stop using our variable sequence going forward. And what I'm going to do is I'm going to talk about our function split using the variable we set all the way up here at the beginning, taxonomy, which has a taxonomy string from Silva. And so you see here, there's some level elements to it that are repetitive. You have this D underscore, which denotes the start of the taxonomic level that you're at. And then some number with some underscores, which also denote the level that you're at. So domain, phylum, class, order, etc., going down. And then there's also these semicolons. And so split works in the way that you might think it might, which is that you can give it a string element and use that string element to divide your string characters into. So what's going to happen is it'll divide your string character based off of those elements, but it's going to put it into a list. And so we're not actually going to talk about lists today. Just show you that this is what happens when you use split And so we'll do that in a couple ways, and then we'll stop there for this particular part of the lesson and move on to our last little bit that we're going to talk about today. So in this particular instance, we're gonna use the delimiters that we have here. So these are the elements that are dividing our string that we have, and we're gonna look at them in a couple different ways, right? And treat each kind of element in its own different way. And so the first thing we could do is we could divide this on our semicolon. And again, like I said, what's gonna happen is that everywhere there's a semicolon, it's gonna split our string. It's gonna keep the elements around the semicolon. The semicolon is gonna be gone. And then those strings are all gonna be put into a list. So what you're gonna see when we say print list 1 is what a list looks like, which we'll get into again in detail in the next lesson. So I'm just gonna run this right now. And what we're gonna see is that our original string, maybe we wanna put that so we can compare it. So if we had our original string and compared it, our original string just looks like this. It's one continuous set of alphanumeric elements. And then when I split with the semicolon is removed, and then each of the elements around it, so everything before here, before this semicolon gets preserved, everything after the semicolon up to the next semicolon gets preserved. And what I do is I create a list, and each element of this list is a string element here, and it's divided from here. And so we can do this a couple different ways, right? So other elements that we might be interested in delimiting on might be this D underscore. And so we can create another variable we're gonna call list2. We're gonna put our taxonomy variable here. We're gonna split. And now instead of a semicolon, we're gonna do D underscore. So you can see here, any string will work for this, and we can do our print statement. We can do list2, and we can print. Okay, so now what we've done is we've removed these elements. And so you can see something interesting's happened here. So the first element of D0 or D underscore happens here. And so we actually are gonna split on this, but because there's nothing before it, when we split it, what's output here in our list is actually a string that has no characters in it. And so you can see here for everything else, what we've done is we've captured that D underscore, this 0 underscore goes all the way up to the semicolon, and then there's the next D underscore. So in our text output, what we're getting in our list is everything up to the semicolon, but this time including the semicolon. And so we can get even fancier. We can make list3 is equal to taxonomy dot split. And in this case, what we'll do is we'll put our delimiter to be our semicolon, D underscore. So now we're capturing all 3 letters. We're gonna print list3. And then when we run that, what we're gonna get is, here, down here. Okay, and so we split our list. Sorry, I was confused by this for a second. Because we had that setting of the semicolon, what we're doing is now it's only capturing these 3 elements together and splitting there. So in our first instance, the D underscore doesn't have a semicolon before it, so it's actually preserved here in the text for the list. But then everything else has now had the semicolon, the D underscore removed, and now is the text going forward here. And so we can also do this. So this is something that Ashley, who helped me design this particular tutorial, suggested, and something that she does commonly with her taxonomy outputs, is you want to find the name specifically of some level of the taxonomic level that we're working with. So in this particular area, we're going to look at the one that is defined by 4 underscore, right? So this would be the equivalent of our family level. And so what we can do is we can do list4 is equal to taxonomy dot split. And then here, what we're going to do is we're going to put this whole element in there. We're going to do semicolon D underscore 4 double underscore, and then we're going to print list4. Now when I run it, this last one that we're going to look at. So here we have everything in this first part of the string up until we get to that D underscore part. And now we have everything in the second part of the string. So that captures our family and our genera, genus that this organism is part of. All right. So there's lots of different ways that we can use split. And then once we'll actually be able to show you once we get into lists, how we can use split to create a list and then manipulate that list to get the outputs that we want going forward. And then the last thing we wanted to talk about in this discussion in particular was the special way that Python deals with its unique characters that are part of the Python code base, essentially. And so we're going to talk about a couple specific examples, including which we saw before, and I didn't go into too much detail of, this /n, which represents a new line in a string. But really what we want to talk about is that the backslash, sorry, down here, the backslash in Python has the ability to force special characters to behave like normal characters, right? So we talked about the single quotes and double quotes denoting strings. So what if we wanted a single quote in our string output? How do we make Python do that? And then at the same time, it also forces normal characters to act as special characters. And so that's a situation where we can use our /n to denote, instead of denoting the letter n, we're actually denoting a new line. And so there's a couple little elements that we can play around with here. And we're going to do two things. We're going to have our string 1, which is going to particularly address the character that we're dealing with. And then we have a plus sign. And then we have this r, which is representing this Python function called rerep or reper, which is a short for representation. And so the format of this is r, double quotes, and then what we want to have it actually genuinely represent in the middle. So in this situation, what we're saying is for r here, or with this r, within these double quotes, take this slash single quote and actually present that in the string. And then we can test that down here. And what we're going to do is after this slash, we're going to replace that element. So in this particular situation, we have this single quote. And then in the second string, we have it lined up in our, so currently it's in our string surrounded by single quotes. So this backslash is going to make it so that this single quote gets printed as opposed to ending our string prematurely. And I'll show you what that means in a second. So if we run this, so the escape character backslash single quote puts a single quote in our string here. And so what I mean by that is, so if I take this out, if I take this backslash out, you can see, and it's kind of a little cheating here with this automatic Python sensitivity of the notebook, is that what it thinks is happening now is that I've written a string that starts here and ends here, and that this element here, currently it doesn't exist, and then I'm starting a new string on this particular single quote. So if I hit enter here, I'm going to get an error. So I've put this back in, I can rerun it, and now this single quote is represented in the string that we want, as we wanted it to be. It's nonsensical as it stands right now, but that's what we wanted it to do. This also makes sense. So if we did it like this, self-aware. Here, so we're using double quotes, so now it's different. Even if I do this, if I do that and replace this, so now it's able to correctly identify that because I've called the string using double quotes, so it's not as confusing. But if I put a double quote here, not like that, I've done the same thing now where I've introduced an end to the string prematurely and then tried to add another string. So we can actually do the same thing here where we do this. I'm going to replace it here so we're looking at that everywhere. And then hit run. And so now I've been able to use the backslash to take our backslash double quote, put it into our string, and then put a double quote here instead of something else. And so we could do this with all these elements, and I'm just going to demonstrate what this looks like. So if we do this here with another backslash, so now we want backslash, and we put it in here, backslash. So what we're asking it to do is, instead of treating backslash as this special character that we normally use to indicate something else, actually print backslash as a string character. So I'll run that. And so now we're getting a backslash in our string. And if we do this for all these other elements, we can do something like this, where we replace this with an N. We can replace this with an N. So this is going to give us a new line. So the escape character /n does and creates a new line for us. And so this is how we represent new lines in text space. So this is an artificial element, right? We've added to it. So now what we're saying is forcibly here is the same as adding you know, a return character at the end of a paragraph. And so we can do this again. So this might not come up too often. People don't normally use these in Python, but the -r or the \r represents a return carriage. And a return carriage is something that you see very commonly in output from Microsoft Office elements. That's what Microsoft Office uses to denote the white space new line. And so we're going to run this. It doesn't actually do much here in Python because it doesn't actually have a function. It actually took this and added it to the front there. I was not expecting that. Okay, might have to revisit this in a future lesson. But it doesn't behave the way that we'd want it to with a new line, right? So even though it's called a return carriage, it doesn't actually do what we want, which would be this, where we print it on a new line. This other element here, where we replace the N with a T, represents a tab. And so what we're going to be doing here is, instead of a new line at the end of this, in between does and test string, what we're going to get is a tab space. And you'll see this pretty commonly as we get further into like the decoding element, where we might want to, what's going to happen is when we do an output, we want to make sure that that output is in a format that might be read at some other point in time, right? So it might be read in a data table. Maybe we want to export it to an Excel spreadsheet. Maybe we want to import it into R. So having a delimiter that's common in those languages is something that happens regularly. And so the /t, the tab, is important there, because we'll probably use that a lot of times to denote what the various columns are in a table going forward. And then the last element that we want to talk about, and I think is pretty interesting, is this \b, which is a backspace. And so when we run this, what's going to happen is that it's going to delete the letter immediately before it. And so you see we remove the S, and now we have a test string there. And so that's what we wanted to do for this particular lesson. We wanted to introduce how these data types work, and then particularly how we manipulate strings and some of the like little kind of nuances that happen with strings. Like I said, our next lesson is going to be working with mutable objects like lists, dictionaries, and sets. And these are the types of elements that really become very common in using Python as you go forward, with terms of making code and making more elaborate elements where you want to do multiple things and keep track of what's going on with those elements as you go forward. Thank you very much for joining, and we'll see you next time.